Hi everyone, welcome to FOSDEM 2022 Apache OpenOffice Verification Testing Talk. I'm Carl Markham and I'm with the Apache OpenOffice PMC. Okay, a little bit about me. I've been with the OpenOffice project, been a committer since 2011, since it was donated to Apache and it was in incubation. I've been on the PMC since 2016, and I'm currently serving my second term as a VP of OpenOffice. The agenda for today, we're going to go over, do an overview of the testing framework, some of the prerequisites that you'll need, go through building and running some tests, how to work on tests, and some of the important classes that you'll need to be aware of. We'll touch on the VCL Assistant tool, which is used for discovering and creating constants used in UI testing. Essentially, the variables that you would refer to the different things like buttons and text fields and things like that. And then finally, I'll show you a macro that I created to import in the test results, which are normally in XML and also HTML format into a spreadsheet report. And then if we have time, we'll go through some questions. So the overview of the verification test suites are that they use the Java programming language and the JUnit 4 test framework. There's four primary test suites. The first two are the ones that I use the most, and that's the build verification test, or BVT. That's a small group of tests, around 50, that verify whether the build is stable before you spend any more time doing manual testing or automated functional testing, which that's the second group there, the functional verification test. There's almost 900 tests in that suite, and that goes through a lot more functionality. And then there's also the last two, the performance verification test and the system verification test. So the prerequisites, you can use Java 7 or 8. Actually, I've even used 11 on the standalone test branch that I'll talk about a little later. And then ANT 1.9 or 1.10, I'm using 1.10. In the Git repo, the trunk branch, it requires having built the office from source before you then compile the test and then run them. The reason for that is there's some jars that are built that are located in some of the output directories from that build. And then there's a new branch that I'm working on called standalone test, where I've separated the test out so they don't require having built the office. So for instance, if you're a developer and you don't build the office normally, but you're a Java developer and you want to work on unit testing, you can do that against either a nightly build that you've installed from our build bots, or even just a regular installed latest version. Either way, and it doesn't require you to have a build system set up. So building and running some tests. After this slide, I'll show you a live example. Well, not live, it's videoed. But to compile the test, like I said before, ant is a prerequisite. So on the command line from the test directory, you're going to run the ant command and then pass in an environment variable, OpenOffice.home, and point it to the office you want to use for compilation. It doesn't necessarily have to be the same office that you're going to run the test against, but it could be. And when I do it, that's usually the way I do it. So the next is an example of actually running the test. There's depending on whether you're on Windows or something like Linux or Mac, then there's either a run shell command or run.bat. There again, you pass in the environment variable for the OpenOffice home, and then there's a switch for the -TP, which stands for test package, and then BVT, which stands for the build verification test we talked about earlier. So that could be FVT or any of the other suites. The next is an example. You don't have to run a whole suite at once. If you want, you could just run a single class that can contain many test methods. And that's the example for that. So it's -TC for test class, and then you give it the package and the class name. And then the last example there is running a single test method within a test class. So the syntax is a little different. It has the BVT colon and then the package and class name, and then dot the test method following that. So next we'll show an example. Here I'm starting with a Ubuntu 18.04 VM with a clone of OpenOffice repo. First I'll check git status and make sure we're on the trunk branch. Next I'll run a build of the office since we're using the trunk branch, and as we said before in the prerequisites that you have to run a build first if you're using the trunk branch. So there's a few steps involved in starting a build, and I won't go into it much except to point out that I'm using an installed type package format. That's instead of RPM and deb if you're on Linux. So what this does is instead of packaging the build into those formats for distribution, it'll create a directory and file layout just as it would look after an installation. And I'll show you what that looks like in the config command that I gave it, since it happened a little too fast. So after our build is done, I'll show you that config switch for the package format. And there's with package format equals installed. So those build directories are buried way down in the folder structure. So what I usually do is I copy them out because right now the SDK and the Office are separate. So what I like to do is create a directory to house the build into, and then I copy both the Office install directory structure and then the SDK into it. So it looks just like it would if I installed it on my system in a different spot, of course. Now we'll move to the test directory. And we'll compile the tests. Now we'll run the BVT test suite using the command I showed you earlier. And through the magic of video, won't make you wait through the 10 minutes. We'll just skip to the end. Okay, now the tests are done and we can view the results. So in the test folder, if you look in the test space directory, which is created if it doesn't exist, there's an output dot and then BVT for the build verification test. There's a HTML file, which is a report shown here. It gives you the total number of tests along with the total failures and errors and any that might be skipped due to not being applicable. There's usually a screenshot link for any of the errors or failures, so you can give you a chance to see what might have went wrong. And then there's also an XML file. Later on, I'll show you how you can use that XML file to import the information into a spreadsheet that's formatted much like this using a macro. So I usually rename these because I often run 3 or 4 of each test suite. So I can look for what we call flaky tests. So over the years, as processors have got faster and faster, it's introduced some flakiness in the test where sometimes you check a result too quickly or something like that. So we've been doing a lot of work on trying to track down those flaky tests and get those fixed. A lot of times it may be just a matter of putting a thread sleep in for a half a second or a second or something like that. Give it time to catch up. So what I'm doing now is I'm cleaning the test out and then also cleaning the Office build. And I was just doing this to show you how when you use the standalone test branch that you can build the test suite without having a Office build. But I won't go through the whole process of running the test again. Okay, so the next thing I want to talk about is the location of the test. So in the repository, if you go into the test directory, right under that, you'll see some directories that are like test GUI, test Uno, things like that, like are shown here. So um, there's GUI test where you're using the UI map, and I'll discuss that in a minute. Classes to manipulate the UI to click on or start with the Start Center, open a spreadsheet, um, click on a button, click into a cell, things like that. The other set of that is the test Uno being the APIs to manipulate the Office. So those would be where you would be using the Uno APIs versus using the GUI. So within those directory structures, you'll see subdirectories like data and source. So data would be where you would put things like images that you want to paste, um, or data that you want to use, or spreadsheets that you want to start with, files, different types of files, things like that. Then the source directories hold the test classes, and then they're further broken down by the test suite that they're in. So you'll see BVT, FVT, PVT, SVT, and so forth. Then you'll see the same thing over on the Uno side as well. So that's how you find the test. So here's an example of a sample test, and this is actually a test. I've took a lot of the documentation comments out so it fits better on the screen. Um, but this comes as part of the test suite, so it's an example test, and this actually runs as part of, I believe it's the functional verification test suite. So you'll see that we're bringing in a logger. There's a comment about that if you actually look in the file, and there's some importance to that rule, as it's called there. And then we have a at before annotation and an at after method till we set up and tear down. So as part of the setup, you'll see we start off with an app object that we haven't declared. So part of one of the things you have to learn as you start using these tests is there's a lot of things there. I don't know if you want to call it injected, or they're just available to start with. So like this app object is I believe it's a VCL app. I'll have to check that on as we go a little further. But then you have the tear down at the end, which takes it all back apart. So then we have the test method, the test hello method. And you'll see here we have a start center object and a menu item method, file new spreadsheet. So all that's kind of or built into this framework. So it makes it really easy to do those tests without having to do a lot of additional coding and things like that calc object for wait for existence. So we're already starting a spreadsheet, and then that tells it to wait until it's available before you continue. And then type keys is yet another method that's already included. And then assert equals is the test assertion. So as you can see there, there's another class called SC tool, and I'll talk about that briefly in a minute, where it gets the cell input based on a string, which is the coordinates of the cell that you want to check. So that's basically the way all that works. So like I talked about, here's the, this isn't all of them, but this is a lot of the ones that I found when I began working on these, working on the OpenOffice test. Because when I first started looking at these tests, I didn't know where, that app object was coming from, or I had to dig through and kind of learn my way around. So that's kind of what I'm trying to show you here is there's a class called UI map, and that contains all the constants for the UI elements, at least all the ones that somebody's used already. And I'll show you in a minute. There's a Eclipse plugin that's used to discover what all those variables are by hovering around the UI, and it dynamically shows you what these constants are. So the next one is VCL app. Like it says, it's a proxy to interact with the OpenOffice. It has those methods like start, stop, quit, exist. VCL window extends VCL control. It's a proxy to access those VCL windows. Then there's the VCL control. Again, here that has methods like click, drag, input keys, type keys, wait for, exist, things like that. There's a tester class. That's a lower level class that it's basically the robot. So if you want to drive the mouse around, sleep the thread, click, drag, things like that, type keys, type text, type shortcut, that's where those live. Then you have app tool. That's the app we were talking about earlier. It extends from tester, so it has all those methods in it, and then it has additional things in it like copy, paste, that start center we touched on earlier, undo, redo, things like that. And then there are some specialized classes, SC tool and SD tool. SC tool, for instance, is utility methods for working with the calc app spreadsheet application. And then I just wanted to throw this other one in, which is a mixed test. And it's an example of tests that use both the VCL GUI library and the UNO libraries in the same test. So this is the VCL assistant tool. Again, this is a Eclipse plugin. I believe it's built for Eclipse Juno, which is fairly dated at this point. but you can still get it and still use this extension. You can download the extension from our wiki, and I've just got a screenshot in here about how this works. So if you have an instance of OpenOffice running and you use the plugin, and as you hover around, you can see down in the lower portion of the screen is the name of the constant that's for that dialog that's highlighted in um, light blue. And if you, for instance, if there's something that you need to use like a text input field or a button that doesn't yet have a constant, you can create it here and it'll add it to the UI map. So I won't go in a whole lot or demonstrate that particular functionality. That's probably a talk all on its own. And then the last thing I wanted to touch on is the reporting macro I told you about. So there's a requirement to doing that, and I'll show you the demo of it. But it requires the Groovy scripting extension. If you caught my talk from last year, I talked about adding Groovy as a macro language to OpenOffice via an extension. So that's a prerequisite to doing this, and then you need to copy the macro off of my GitHub project, and I'll show links at the end to all this. And then the next step is start a new spreadsheet, and then run the macro, and then select that result XML file, which has the test result in it. So I'll show you that next. So the last thing I want to show you is the macro to create the spreadsheet report based on the XML file. So just as a reminder, this is what the HTML report looks like that you get from JUnit. So what I wanted to do is do something in a similar fashion using a spreadsheet. So you want to make sure that you have the Groovy scripting for OpenOffice extension. You can get that from extensions.openoffice.org. Again, there'll be a link for that. And then once you have the extension installed, then you have Groovy macros available. I've already created this macro, but I'll explain. All you need to do is create a new library and then a new macro, and then copy and paste the text of the macro from my GitHub page. And I'll show you that. Here's the macro from the GitHub page. You can just click on raw, get the raw text, and copy and paste over top of the boilerplate code that's that you get when you create a new macro. So I'm going to go ahead and run that macro and then import in the XML from the result XML file. You'll see it imports in the data and then formats the spreadsheet. Freezes the row. Then you can begin to filter by failure, error, things like that. So that's it in a nutshell. Okay, here's the links I promised. And if QA testing interests you, whether it's creating them or running them, please join us. If you need help finding anything, you can ask on the OpenOffice developer or QA mailing lists. Thanks for taking the time to join us today.